So 0.5 is the chapter that we will be doing today. And chapter 0.5 is basically factoring, right? And I'm gonna try to move a bit faster, guys. Because we have to get to chapter 2. And I see that a lot of people were struggling with apparently are struggling with chapter 2, right? Which is your um the domains and so forth, your case defined functions and all of that, right? So we need to get to that chapter as soon as possible. Okay, so let's get going. Okay, so we are now on chapter 0.5, which is factoring. And this chapter, I'll basically start it off by explaining some of the rules of factoring, right? And then after that, we'll do a couple of examples, and then we'll be done with the chapter, right? It's fairly a short chapter, right? It's fairly a short chapter, and also I'm expecting all of us to be familiar with it, right? So rules for factoring. Okay, so we have a couple of rules, and I'm sure that you guys are familiar with them as well. Please, 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 please be familiar with them, guys. I'll be shocked if you guys are not familiar with it, right? So the first, what do you call it? Rule that you should be familiar with is common factor, right? Which, let's say x times y plus x times z, right? And in order for us to find the common factor, we need to take out the x. That would be our common factor in that case, right? You guys, I'm sure you know this one. So we take out a common factor of x, we'll be left with y plus z inside the brackets. All right. You guys can hear and see my screen, right? You can hear my voice and see my screen. Just put a thumbs up, right? Okay, perfect, 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 perfect. And the second one that we would have, right? And basically, this is just the opposite of what we did in 0.4, right? We are factoring. We basically have an expression, right, that we got from foiling, right? In the last chapter, we had two brackets that we had to multiply together. This time around, we have an expression, and then we have to go back those two brackets. Are you guys with me? So this expression that we have, I have x squared plus a plus b multiplied by x plus ab. And they basically want us to go back into the two brackets format. So that will basically be us opening two brackets. And then all we have to do, we just have to look at these values over here, right? So we have our x squared. So I'll distribute my x and my x as well. And then we have a and a b. I'll distribute my a over there, and I'll also distribute my b over there. So how do we get the middle, the symbols? How do we get the middle symbols over there? How do we get to those? That's pretty simple. All you need to do, right, is you need to look at the variables that we're given over here. You can see this is a positive a and this is a positive b. So this means that they use the positive a over there and the positive b over there. Because when you multiply these two together, they give you a positive AB as well, right? We'll go further into those when you do the examples, right? You'll see what I mean by that, like properly. So that will just be the final, what do you call it? Final answer. And I'm gonna head over to the third one, which says x squared plus 2ax plus a squared. This is the exact same thing as what we have done previously, guys. The exact same thing as number 2. We just open two brackets. They want us to factor, to do factoring over here. We distribute our x as well. And then what do? We distribute our a, and we distribute another a, right? And then what do? We have 2ax. So I'm sure at one point this was a and this was also another a, right? It's ax plus ax. Do you guys agree with me on that? Just put a thumbs up. At one point, that was a positive ax plus another ax. So which means I just need to use a positive and a positive over here. And that's what I have. Okay. So seems like you guys are fine with this. This is the exact same thing. Let's do one where we have a negative, right? So let's say we have x squared minus 2ax plus a squared. We do the exact same thing, guys. The exact same thing. When you do factoring with a trinomial, you always open two brackets. You distribute your x. You distribute whatever you have over here in the last term, which is your a's. And then after that, what do you do as well? You now need to just find out what symbol to use over here in the middle, right? And that's fairly simple. I hope you guys agree that we can say negative ax and another ax, negative ax, and then that will give us a negative 2ax, right? So this means that they used a negative value, a negative a, negative a, negative a. So I'm going to say negative, negative, and that's it. Are you guys okay with this? Okay, perfect, 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 perfect. It's pretty simple. These rules are pretty simple. That's why I feel like we can go over this chapter fairly quickly, right? Okay, so the next part that we have, I want you guys to now identify that for number 5, right? The next rule that we have, it does not have a middle term. This term is non-existent, right? So what do we do in this case? I'm sure you guessed it. We open two brackets as well. And this is what we would call a difference of two squares, right? And basically, it just refers to what you see over here. These are two squares, and there's a difference, which is your negative symbol. Difference of two squares, right? That's how you identify what it is. So for our difference of two squares, it's quite straightforward. Distribute your x as well, distribute your a's, and then you always just put a positive symbol over there in the first bracket, and in the second bracket, you just put a negative symbol. Are you guys fine with this? So let's maybe do an example of difference of two squares, right? So a difference of two squares example would be, let's say, x squared minus 9, right? So x squared minus 9, remember, we can write this as x squared minus 3 squared, right? And then that's when you identify that this is a difference of two squares. And what do I do from then onwards? I just open two brackets. I distribute my x values. I distribute my 3 and my 3. And then you just have to remember that Mr. Booth told you that you use two different symbols for the brackets. Then you're done. So that's how you do factoring with the difference of two squares. So I'm gonna assume that you guys are fine with it because you did place some thumbs up in the chat. If you guys have any questions, guys, please don't be afraid to ask. If you feel like I'm going too fast, just please do let me know as well. All right. Please do let me know as well. Don't be afraid to ask. So number 6, we have the sum of two cubes. And this one is my favorite because, it's always the same. It's never difficult, this one, right? So we have the sum of two cubes. And basically with the sum of two cubes, as you can see, we have x to the power of 3 plus a to the power of 3, right? That's the sum of two cubes. With this one, I always want you to open a small bracket. I always want you guys to open a small bracket And then I want you guys to open a big bracket, right? And then in the small bracket, we will distribute one of these variables. So I'm going to distribute one of the x's and I'll distribute one of the a's. And then I'm going to do the exact same thing for the second bracket, right? For the second bracket, the bigger one, I'll distribute 2 or x squared, right? Then I'll also distribute a squared, right? My remaining values or my remaining, powers. And then what happens with the symbols and also this middle term? How do we get to that conclusion, right? For the first bracket, we have x and then an a, right? And then we need a middle symbol over there. So the symbol that where do we get that symbol? Sorry, we will get it from this symbol that we were given already. So I'll just put in a positive over there. And the next symbol that we get it from this bracket, but it's just the opposite. So basically, it's going to be a negative. So we take the opposite of this symbol. Are you guys with me so far? I'm sure you guys are fine with the distributing of the x and the a's, but are you guys with me so far with the symbols? Is everyone with me? Just put a thumbs up before I move on. Okay, perfect. So what happens with the middle term? So with the middle term, you just take this a and this x, and then you multiply them together, and that will give you ax. And then for the last symbol, this is always a positive. For the last operation, it's always a positive. So are you guys fine with how I got to this? I'm just going to do the exact same example, but with a negative symbol. So the difference of 2 cubes. Okay, it seems like you guys are fine with it. So let me do it one more time, but with a difference of 2 cubes as well. So we have x to the x cubed minus a cubed. We do the exact same thing. We open one small bracket and we open one big bracket as well. It distributes one of my x and one of my a into the smaller bracket. And then I just also distribute this negative symbol over there. And then I distribute my x squared and my a squared, right? And then the next operation of the next symbol that I need to place would be opposite to the symbol that we were given originally. So in this case, I'll just place a positive over there, right? Positive is opposite to this, right? Let me just write it down so that you guys can see what I did. And then the next term, we will get it by multiplying these two together. So your ax. And then remember the last, what do you call it? The last symbol is always a positive. And then that's it. So are you guys okay with this? So those are our rules of factoring. We have basically covered all the rules of factoring, and then I would just like to do examples with you guys, right? So that we can further solidify the information that I just taught you guys. So please repeat on how we find the middle term. Okay, so for the middle term, you just basically take this x and this a, then you multiply them together, ax. The a and the x, multiply them together, ax. That's always the case. You just multiply those two terms together from the first bracket. And then just leave the symbols. Just leave the symbols. Don't add any symbols. Just multiply the a and the x, ax alone as every single time. Are you fine with that? Just put a thumbs up if you're fine with it. Okay, perfect. Now let's move over to examples, right? Need to do a couple of examples now. Okay, I want us to do a common factor question. So let's first do a common factor example. And I'm gonna immediately jump to the hardest ones, right? There's no use of us doing the easiest ones because I feel like you guys already know how to do those ones, right? So the hardest common factor type of question that will give you is something like this, all right? Let me first write it down. This is the hardest they can give you. They can give you a hardest, what do you call a common factor question. You just see that it's not difficult. It's just a lot of what do you call it? A lot of variables and terms. Okay. So in this case, they want us to find or factor this completely, right? So they just want us to factor this completely. So you just need to find a common factor and take it out, right? So already with the numbers, let's start off with the numbers. I can take out a common factor of 2. You guys agree with me on that? I can take out a common factor of 2. And then let's head over to the A's. What's the lowest A number that I can take out? It's A squared, right? I can take out an A squared on each of these terms, all right? Do you guys agree with me on that? Then let's go over to the B's. So with the B's, seems like I can't take out a common factor of B. And the reason for that is because the B does not appear in all the terms. It only appears in these two. And we can't take out a common factor for it, right? And then let's look at the X as well. So even with the X, we can't take out a common factor of X because it does not appear in every what do you call it, in every term. But it seems like our Y does appear in every term. So I can take out a common factor of Y because, okay, here's y to the power of 1. So we can take out a Y to the power of 1 on each of these terms. And then what about our Z? So with Z, we also can't do anything. And that's it. That's basically the common factor that we can take out. So we'll basically have 4 a to the power of 3 x squared y to the power of 2 remaining in the first term. I hope you guys agree with me on this, right? Minus 3, and then there's no more a's. B to the power of 3, and there's no more y's as well. And then we just have a z remaining. Minus a to the power of 2, b to the power of 4, and then our x remains as well. And then we only have one y remaining and a z squared. And that will be our final answer. Are you guys okay with this? Perfect. It was pretty simple, right? Pretty simple. Okay, so let's move over to the next part. Let us factor out some trinomials, right? Let's factor some trinomials completely. Okay, perfect. So I see you guys are even putting a thumbs up, so it's fine. You guys are understanding this. I'm glad. Okay. So they want us to now factor 3x squared plus 6x plus 3 completely. Okay, so how do we factor this out? We just need to first, I see a trinomial, right? So eventually it looks like we would have to open 2 brackets, right? But first things first, I would like to do is take out a common factor of 3. So if I take out a common factor of 3, I basically have x squared plus 2x plus 1 remaining inside the brackets. And then I can now take this part, right? I can now factor that part as well. So factoring that out, I can take out, I can open 2 brackets, right? And then I distribute my x's, and then my 1 and my 1 as well, right? And then basically, in order for me to get the middle terms, or the middle, sorry, not the middle terms, the middle symbols, let's find the multiples of 1. The multiples of 1 is just the 1 and the 1, right? And these multiples of 1 that I just found, they need to give me this middle term. So the plus 2. And I can get that plus 2 by saying plus 1 plus another 1. Are you guys with me on that? Are you guys with me on how I got to that? And then I'll just answer the questions on the chat in a few. Okay, perfect. So our final answer in this case is 3x plus 1 squared, since these are the same. Okay, so in the chat, we have students asking if we are allowed to use the quadratic formula, right? So please, 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 please do not make this mistake, right? Do not use the quadratic formula if it's not an equation, right? This is just an expression. If it was 3x squared, right, plus 6x plus 3 is equals to 0, then you could use the quadratic formula because you want to because you want to find, what do you call it, your x value, right? In this case, they don't want you to find your x value, so you don't have to use the quadratic formula. But there is a trick of using the quadratic formula, to find these two brackets. But I feel like let's keep it like this so far, and then maybe later on I can tell you guys that trick. Are you guys fine with that? Or do you guys want me to show? Or do you guys want me to show you guys now? But I'm just afraid that you guys would make a mistake and change this completely to an equation when it's not an equation, and then you end up solving for your x. Okay, so let me just show you. It's fine. Let me just show you. If you use your quadratic formulas, right, which is a negative b plus or minus the square root of b squared minus 4ac divided by 2a, right? If you use your quadratic formula, right, and you plug this in, this as your a, this as your b, and this as your c, right, you get that your answer will give you x is equals to 1, sorry, negative 1, right? Or x will also give you a negative 1 if you change the symbol, right? So this is up to you. In order for you to find those brackets, all you have to do, you can just take this negative 1 over to the other side, and then you would have x plus 1 is equals to 0. X plus 1 is equals to 0. And then you just know that this is the brackets that you need to use. Are you guys fine with this? You just emit this part. You just emit this part, and then you just know that those are the brackets that you need to use. Okay, perfect. Why isn't the answer the same when factorizing by grouping? Okay, so just please show me what you did. You shouldn't group in this case. What did you do over here? In this example, you should not do grouping. So just please, Patricia, just please show me how you did the grouping, and I'll just correct you and show you why you shouldn't do the grouping in this case. Why you shouldn't factorize by grouping. Okay, so you said 3x plus 3 and then x plus 1. Okay. So I'm assuming that you probably did that method where let me just erase this. Did you do the method where you've multiplied these two together and then you get 9x squared? And you find the multiples of the 9x squared, and then that's when you end up grouping at the end. Is that what you did? Okay, so it's still 100% correct, because just look at your answer that you got over there. You got 3x plus 3 multiplied by x plus 1, right? So you can take out a common factor of 3 over here. And then you just have your x plus 1 and then x plus 1 as well. So you can definitely do that, Patricia. That's correct. It's just another, way of showing it. But I would prefer for you to either use this method that I show you guys, um, or you can use, the other method that I also show you guys over showing you guys over there. And this thing does not want to come out. Why? Yeah, I might have to use a new board because this thing does not want to come out and it's gonna irritate me. Just give me a second. Okay. So let's move over to the next example. Right. Let's do this one. So we have 8 minus x cubed, right? And they basically want us to factor this completely as well. So does anyone wants to attempt this question? Anyone wants to attempt this question? Okay. Keith, I see you raised up your hand. You may attempt the question. Okay. So Patricia is saying that we can say 2 to the power of 3 minus x to the power of 3 as well. Okay, so we are still not on synthetic division, right? We are not on division as of yet, right? So just let's not do division. Let's just stick to to what we're doing today. Okay, so we have 2 to the power of 3 minus x to the power of 3. And then Tlaisani, I see you raised up your hand. Anyone wants to go further from this? Snovuyo? You may answer the question.
Can I answer that?
Yes, you may.
Yes, you may. So what I think is that we're going, since it's difference of 2 cubes, so we're going to open 2 brackets. The first one is going to be small, and then the second one is going to be large. And then we're going to put on the first bracket, we're going to put 2 minus x. And then on the second one, we're going to put 2 squared. And then we go to the last to that space on the last bracket, and we're going to put x squared. And then since it's always positive, we're going to put positive there. And then we're going to multiply the terms on the first bracket, which is going to be 2x. And then we're going to take the positive of the negative, the positive of the first bracket, which is going to be positive.
Okay, perfect. So that's the correct. Just please mute your mic. Okay, perfect. Okay, so thanks to who was it? Was it Sinovuyo? That is the correct answer, right? Correct answer, perfect. So basically all you have to do over here, you have to identify that this is a difference of 2 cubes, right? Even though the order is a bit, different to what we're used to, but it's the exact same thing, right? It's the exact same thing, right? Okay. Let's do one more example as well, or 2 more actually. Let's do x to the power of 4 minus 1. Yes, I would like us to do this one. I would like for us to do this one. What do you guys think? Does anyone have that? Do we have any takers for this one? I see Tatabelo is putting a thumbs up. So Tabero, let's answer the question.
Okay, so say what I think is that we've got x to the power 4 minus 1. And then since 1 can always be written as 1 to the power of any number, so we're going to say x to the power 4 minus 1 to the power 4. And then we're going to yeah. And then we're going to say equal to, and then we're going to open 2 brackets. On the first bracket, we're going to say x squared minus 1. To make it more easier to understand, just write 1 squared. And then on the second bracket, we're going to say x squared again. And then on the last one, on the bit on the last, we're going to say 1 squared. And then since it's always positive, we're going to put a positive there. No, like just a big big bracket on the second one.
Okay.
Okay.
So
No,
okay,
it's
just
not.
please.
It's not. I'm not done.
Okay, wait. Just please mute your mic,
Mute your mic.
and then
And then
I'll
I'll.
show you.
Okay.
So you were
So
doing
you were
it
doing
correctly.
it correct.
Yes.
Um, just please mute your
Just
mic
mute
so
your
I
mic
can
so I can.
explain. Okay.
Okay.
So
Yeah.
Tabero, just please
Tapero,
mute your
just
mic.
please mute your mic.
Yeah. I can't hear you.
Please mute your
Please
mic.
mute your mic.
Okay. Yeah. So we're going to say, and then we're going to say plus x squared.
Okay.
Okay.
Plus 1 squared.
Okay.
Okay. So
Let me just mute
let
your
me just
mic,
mute your
right?
mic, right?
Yeah.
And then I'll
And
show
then
you
I'll show you
where
where
you did the
where you
mistake.
did the mistake.
Yeah.
Okay. So Tabero, everything that you did, right, up until the last bracket is okay. So that's why I was trying to stop you over there. I was trying to stop you because I wanted to correct the mistake that you did over there, right? So everything over here is correct. Let's just take out this bracket now, right? So the moment what do you call it? The moment we have x to the power of 4 minus 1, right? You were correct by saying we could change this to what do you call it? Minus 1 to the power of 4, right? That's 100% correct. You can do that. But you need to open two small brackets this time around because this is a difference of two squares, right? It's not a difference of cubes. If you had a difference of cubes, if you had x to the power of 3, then that's when you would open a small bracket and a big bracket. In this case, all you had to say now is you had to distribute your x squared and another x squared, and you just put a positive symbol over here. And then you say 1 squared as well. Then let's just remove these squares. Then yeah, that's basically all we had to do. This would be your final answer. Are you guys okay with this now? Okay, perfect. So just please be careful of that, guys. You can it's very easy to make mistakes. Just please be careful of that. And then I said I wanted to do one more. We have E, and E is basically Z to the power of 1 over 4 plus Z to the power of 5 over 4. Then I want you guys to factor this completely. What do you guys think? What do you guys think we can do over here? I just want us to factor it out. What do you guys think we can do over here? Do you agree that the only thing we can do over here is find the common factor? And the common factor in this case would be the Z to the power of 1 over 4 multiplied by, this will give us a 1 plus a Z. And this would be our final answer. Okay, so that's basically all we needed to do. It's very rare for them to give you such questions or in your tests, right? It's most likely going to be a bit harder. Okay, so let's go over to J, which you guys requested for us to do. And this says x to the power of 6 minus y to the power of 6. And I see we have a taker in the chat, Khalifo. I see you want to do it. You can definitely unmute your mic and attempt the question. Okay,
Sure, guys. First thing
okay.
we are going to do, we are like fourth root of z plus fourth root of z to the power of 5.
Wait, you're doing this one.
Yes. E, please.
Okay, but we already did the answer though. Okay, but yeah, we already did the answer.
Okay, no
Eh,
problem.
eh, please try this one for us. This one, x to the power of 6 minus y to the power of 6. And then before the previous answer, final answer, isn't it supposed to be x minus 1 to the power of 2, x squared minus 1? Okay, so I think, yeah, we can definitely just simplify that further. Let me just do it real quick. So this is basically like this, right? So the only thing over here that we can simplify is the x squared minus 1, right? Which is the difference of two squares. This one, we can't do anything to it, so we just leave it as it is. But this difference of two squares, we can open two brackets. And then we can distribute our x and another x, our 1 and another 1, and then a positive and a negative. And this would be your final answer for that part of the question, right? Okay, so I hope you guys understand why we could go further over there, because this is a difference of two squares, this specific question. Okay, so let's go over to x to the power of 6 minus, can you please explain answer on letter E? Okay, so let's explain it like this. We'll head over to x to the power of 6. So please, guys, don't just put a thumbs up if you actually don't really like fully understand it, right? I'm here to make you guys fully understand this and have no doubts about these questions, right? Okay, so with E, what we basically did is we took out a common factor. We see we have z to the power of 1 over 2 and z to the power of 5 over 4, right? We can't open two brackets. We can't do anything else except the common factor, or taking out a common factor of z to the power of 1 over 4, right? I hope that you guys agree with me. We can rewrite this thing as z to the power of 1 over 4 plus z to the power of 4 over 4 multiplied by z to the power of 1 over 4. Do you guys agree that we can write it like this? Because when we multiply these two together, it will give us the 5 over 4 when we add the exponents together. Okay, perfect. So now once I can write it like this, I can take out a common factor of z to the power of 1 over 4. So z to the power of 1 over 4, I took out a common factor. And then in this term, I just have a 1 remaining. And then in the next term, I have a plus z 4 over 4. Are you guys with me? And then when I just simplify that 4 over 4 is just going to give us a 1, right? So that's just 1 plus z. Okay, perfect. Let's go over to J now. And I see Anatemba has an answer for us there. Let's see if we can get to the same answer as her, right? So we have x to the power of 6 minus y to the power of 6, right? And basically what I'm going to do over here is I'll break this down. I'll write the x to the power of 6 as x to the power of 3 squared, right? Minus y to the power of 3 squared as well. Squared. I'll write it like this. This is the exact same thing. I have not changed anything, right? And then what am I able to do now? I see a difference of two squares. Do you guys see it? Here are our two squares, and then we have a difference. These are our two squares, as you can see them, and here's our difference between them. So this means I can open two brackets, right? And when I open two brackets, I'll distribute one of these. So I'll distribute x to the power of 3 and an x to the power of 3. I'll distribute a y to the power of 3 and another y to the power of 3. And since it's a difference of two squares question, I'll have a positive and a negative. Are you guys okay with this? So far, we're not done as of yet. Okay, so what do you guys see over here? What do you guys see with each of these? Because on my side, I see a sum of 2 cubes and a difference of 2 cubes as well. So what do we need to do? This is when we can now open. So I'm gonna start with this one, right? This one that I just named number 1, and I'll head over to the second one as well. So the one that I named number 1, let me open a small bracket for it and a big bracket for it. And then we just do what I taught you guys to do when we have a difference or a sum of 2 cubes, right? And this positive will go over there. And remember, this is always a positive as well. And this symbol is opposite to the first symbol. And then my x times y. And that's what we have for the first sum of 2 cubes. Are you guys okay with that? So this is for this part. Are you guys okay with that? Are you sure? Is everyone okay with this so far? Okay. So now I'm going to do the second part, which I'm going to highlight in green. This part, I'm doing the exact same thing. Exact same thing. Open one small bracket and one big bracket. Distribute my x and my y's. And then I distribute my negative symbol. And the second symbol is always opposite to the first symbol. And the last symbol is always a positive. And then in my middle term, I'll just have my x and my y. And that's it. This will be our final answer. So I'm just using highlighters to show you guys how the two sections look like. Okay, perfect. So I hope you guys are fine with this, right? I hope you guys are actually fine with this. So I'm gonna propose a structure that we need to use, right? Every single month, I would like for us to write a practice test. Is that fine with you guys? Every single month, we write a practice test. And as I told you guys before, this module is very fast-paced. I think you only do it in the first semester, if I'm not mistaken, right? So by the time you are near the exams, we would have finished probability, we would have finished differentiation, we would have finished calculus parts, everything. Even integration, we would have finished it, right? So that's why I would like for us to always keep up to date and write tests every month. And I'll also give you guys homework every week, right? Okay. So let's head over to the next part. We will do fractions now, right? 0.6. We are done with 0.5. It was a short chapter. So for 0.6, I'll only do the multiplication and the division of fractions, right? And then we'll call it a day. Is that fine with everyone? Or do you guys want to go over and just finish the whole of 0.6? But I feel like if you just do if you do multiplication and division, we'll be fine, right? I don't want to overload you guys with a lot of work or information. Okay. So we are now on chapter 0.6, which is fractions. And this is my favorite chapter because it's the easiest chapter, even though people may struggle with it, right? But it is actually the easiest chapter. So the first thing that I'll teach you guys is simplifying fractions. This is what you always need to do when you get a fraction. You always need to try and simplify it, right? No matter what type of fraction you have, always try to simplify it to make it easier for yourself, right? And simplifying fractions, let's say we have an example that says x squared minus x minus 6 divided by x squared minus 7x plus 12, right? When we get such a fraction, they'll just tell us to simplify it, of course, right? Please do number 35 of the problems of 0,5 after you're done with 0,6. Okay, another problem, we'll do that as well, which is 35. 35. Okay, we'll do it, don't worry. Okay, so let's head over. Let's continue with this one. In order for us to simplify this, right? All we need to do is we just need to factorize the numerator and the denominator. And by that, I'll open 2 brackets in the numerator, and I'll also open 2 brackets in the denominator. I'm not doing common factor because I can see that my x is not present in each term, right? I see a trinomial, so immediately what comes to mind is opening 2 brackets. So in the numerator, I will have my x and an x over there. In the denominator, okay, let's first do the numerators first. So in the numerator, I need multiples of 6 that will give me a -1. So there is no ways on planet Earth that I can add a 1 and a 6 and somehow get to a -1. But we can use a +2 and a +3 to get to a -1. So we can use a 2 and a 3 to get, to a -1 somehow. If we say a +2 and a -3. Are you guys fine with this? Just hit me with some thumbs up. Just hit me with the thumbs up. We don't want to leave anyone behind, right? We want to, everyone must get distinctions. Check. Okay, so let's go over to the denominator. So the denominator, we have our x as well. We can distribute those ones. And then now we just need to find multiples of 12. That will give us a -7. So we can say 1 and 12, 2 and 8, 2 and 6, sorry, 2 and 6, 3 and a 4. So the only one we can use over here is the 3 and the 4. If we say -3 minus 4, all right? And then what do you guys see? We can cancel out the -3 and the negative x minus 3 and the x minus 3. And then we can now have x plus 2 in the numerator divided by x minus 4 in the denominator. Pretty straightforward, right? Okay. And also, before we move on, just please let me know which topic are you guys at right now in class? Which chapter are you guys at right now in class? Because I feel like we actually should move a bit faster than functions, which is chapter 2, right? Chapter 2, composition of functions, 2.4, right? Somewhere around there. Okay, perfect. Okay, so that chapter, we will get to it. Do you guys do chapter 1? Or they just jumped it? Applications of, okay, so they jumped it. Okay, so we'll just jump to chapter 2 as well, as soon as we are finished with this. Okay. So let's head over to the next thing. Should we do one more simplifying? Isn't it -1/2? For which one? -1/2. Patricia, just please let me know where you're referring to. -1/2. Cancel the x's. Oh, okay, no. Please don't do that. Please don't do that. Right? Please do not do that. The only way you can cancel x's is if let's say there was an x multiplying like this with each other. Then you can cancel the x's. In this case, right? This is one expression. Consider this as one expression, right? These are 2 different expressions. You can't just cancel out the x's and leave what's it called? And leave the +2 and the -4, right? So yes, if they were single terms, you could do that. But in this case, they are not single terms, right? This is one full expression. This x minus 4 is one full expression, right? Please don't make that mistake, guys. So if this was x minus 4, you could cancel them out. You could cancel them out because they're exactly the same. But in this case, these are two different expressions. So leave them as it is. Okay, do you guys want us to do one more simplifying of fractions, or do you guys want us to head to multiplication and division of fractions? Okay, let's do one more. So one more, we have, let me just choose one from the questions. Actually, these examples are too simple. Okay, let's choose this one. Let's choose, I'm on problem 0.6, which is I'm doing number 6 of problem 0.6, right? They will just want us to simplify. And this says 6x squared minus 19x minus 7. And this is divided by 15. The problems is, it's on problem 0.6 page. What page is this? Page 48. The questions are at the end of the chapter. So I'm doing question 6 over there. Okay, so this is what we have, and they just want us to simplify this, right? So for the numerator part, can we open two brackets? Can we take out a common factor? It doesn't seem likely we can't, it seems like we can't do that, right? Do you guys agree with me? We can't take out a common factor, and we can't open two brackets. You can open two brackets if you want to. Okay, so Khalifa is saying we can use quadratic and reverse. That's 100% correct, right? So there's two methods that you can use over here. There is one way you can multiply. What do you call it? You can multiply these two together, and then you find the factors that will give you the negative 19, the middle term, right? When you multiply these two together. Or you can use the quadratic and reverse. So do you guys want me to show you both ways, or do you guys want me to show you the easier method, which is the quadratic and reverse? Okay, both methods. So let's start off with the grouping method, right? Okay, so I'll just write it over here. Grouping method. So let me show you guys both methods. Okay, so for the grouping method, or the first method, the method that we have to multiply the first and the last term together, right? So once you've multiplied the first and the last term together, negative 7 times 6 should be, is it 42? 48, 48, 42, I think it's 48, right? So we will have negative 48. So we will have negative 48x squared. Do you guys agree with me on that? Oh, 42, sorry, 42. Okay, so we have negative 42x squared. I hope you guys agree with me on that. So we just need to now find the multiples of negative 42x squared. That will give us a negative 19. So I'm going to write them down all. I'm going to write all of them down here. So we can say we can say x multiplied by 42x. That's going to give us that 42x squared, right? Let's leave that negative symbol as of now. We can say 2x multiplied by 21x, all right? And it seems like we can use this one to get to our negative 19x, right? If we say if we say negative 2x plus 21, no, my bad. If we say negative 21 plus 2x, negative 21x plus 2x, we can get to our negative 19x. Do you guys agree with me on that? Okay, perfect. And then what happens over there, we will say 6x squared, right? Because we now know we just need to use this. And then we will rewrite the negative 19x as 2x minus 21x. And then minus 7. Do you guys agree with me on this as well? Just put a thumbs up. Is everyone fine with this? I only see one person raising up there, putting a thumbs up. Okay, perfect. So once we get to this point, this is when we do the grouping part, right? So we'll just group these two together and group these two together as well. So I can take out a common factor of, what do you call it? 2x, right? Then I will have 3x plus 1 remaining. Then likewise, I can take out a common factor of negative 7, right? And if I take out a common factor of negative 7, I will have 3x plus 1 remaining as well. And then that's when we can group them together. We can group the 3x plus 1 together. And then we also have the 2x minus 7 remaining on the outside. And then this is what we will have in the numerator. And then you also do the exact same thing for the denominator if you wanted to, right? But I feel like this method is quite long. It's good to know this method as well, you know. But it's quite long. It's better to just use the quadratic and reverse method. But okay, perfect. So for the numerator, we will use we use the grouping method, right? And then for the denominator, we will use the, what do you call it? The quadratic and reverse method, right? Just to show you both methods in one go. Okay. So for the second part, I will use my quadratic quadratic and reverse. And basically, I'll use this formula, negative b plus or minus square root of b squared minus 4ac divided by 2a, right? This is our quadratic formula, right? And when I use it, I will use this as the a, this as the b, and this as the c. Please plug in the values and please tell me the answers that you get when you use the positive and also the negative version. What do you guys get for your x values?
7/2 for the first one.
Okay, so for the first one, you get x is equals to 7/2, né?
Yes.
And then for the second one,
It's negative.
sorry, just please repeat.
It's negative 1/3. It's negative
Okay,
1/3.
so this is what we get, right? And then why they call it the quadratic and reverse method is because you just need to take this whole thing over to the other side, right? You just need to take this whole expression over to the other side, and then you will basically get what you need to write inside your terms, right? Your brackets. So this 2, it's dividing this side. If I take it over to the other side, it's going to multiply with the x, right? So I basically have 2x is equals to 7, right? Let's do the exact same thing for this side. This side, I have 3x is equals to negative 1. And then this 7, I can take it over to the other side. It's going to minus, right? I will have 2x minus 7 is equals to 0. And this side, I will have 3x plus 1 is equals to 0. So these are my 2 brackets that I need to use. And then you just remove this 0. Are you guys okay with this? So I basically have 2x minus 7 and then 3x plus 1. So I got to the 7/2 by using the quadratic method. So we said for the numerator, we will use the grouping method. And then for the denominator, we will use the quadratic method, quadratic and reverse method. So that you guys can just choose which method is best for you. And we got to the 7/2 by plugging We got to the 7 over 2 by plugging the 15 as the A, the 11 as the B, the 2 as the C in our quadratic formula, right? And then if you use a positive over here, I think this is the one that gives you the 7 over 2, right? Then if you use a negative, this is the one that gives you a negative 1 over 3. And then people are saying they're getting 2 over 5. Okay, so let me just place it in myself, right? Where's my calculator? So let me just place it in myself. The numerator and the denominator can be the same, right? So it just means it's going to cancel out and then your answer will be 1. But let's just make sure that we do not make any mistakes over here. So negative b, which is 11, right? Plus the square root of 11 squared minus 4a, which is 15c, which is 2, divided by 2 multiplied by a, which is 15. So for the positive symbol, right? So for the positive symbol, I'm getting negative 1 over 3. And then let's use the negative symbol now. So for the negative symbol, I'm getting negative 2 over 5, right? So the person who got 7 over 2, right? Just please double check your answer. So the answer should be negative 5 over 2. So in this case, let's just change everything up. So I'm getting 5x is equals to negative 2. And then when I take this negative 2 over to the other side, I basically have 5x plus 2 is equals to 0. So this is my other bracket, basically. This is my second bracket. So let's remove the wrong bracket, which is this one. And then there we go. I've shown you guys both ways we can do the simplifying, right? We can factorize. So it's just up to you to choose which method you would use. Personally, I like using this method, right? I like using this method personally, because with us, we are not, on my side, we're not allowed to use calculators, right? When we are doing our mathematics, right? So that's why I'm more used to doing this method, and you see me using this method more often, right? And then yeah, but you can use any method you want. That's up to you. The 3x plus 1s will cancel out. In our final answer, we would have 2x minus 7 divided by 5x plus 2. So that'll be our final answer. Are you guys okay with this? Okay. So let's just do the multiplication and the division of fractions, and then we would be done, right? So we'll be done with today's lesson. Okay. So multiplication of fractions is the simplest type of fractions that you can get, right? Multiplication of fractions is the simplest, and when you get it, you should definitely get full marks for it, right? You should be happy that you're getting such a question in your tests or exams, right? And it's very unlikely that they will just give you a multiplication of fractions. Questions are low. They usually give you all of the types of fractions or the operations of fractions combined, right? They give you all of them in one question. So we will do all of those later on when we are all done with all the types of operations of fractions, right? So right now we'll just do multiplications of fractions, and let's start off with the rule for multiplying fractions, right? So the rule for multiplying fractions, it's quite simple, guys. Very, very simple. Make sure you do not forget it. So let's say we have A divided by B, and this is multiplied by C over D. So we have A over B multiplied by C over D. And this is us multiplying two fractions together, or two and more fractions together, right? What do we do over here? We just multiply the numerators by themselves. Then we also multiply the denominators by themselves. And that will be our final answer. As simple as that. So our final answer would be AC divided by BD. Pretty straightforward, right? So let's do examples now. That's the rule. You don't need to know anything further. That's all you need to know for multiplication of fractions. So let's do examples now. I have an example that says x 2x divided by x minus 5 multiplied by x plus 4 divided by x plus 1. And they basically just want us to multiply these two fractions together. So remember, multiply the numerators by the numerator, and then you multiply the denominators by the denominator. If you ever change this up, you are gonna get it incorrect. It's gonna be incorrect, right? So just keep it simple. Do not overthink this. Just keep it simple and straightforward. So we basically have 2x multiplied by x plus 4 in the numerator divided by x minus 5 multiplied by x plus 1. And then when you simplify this, no, you do not cross multiply. You see, you do not cross multiply. Please do not cross multiply. So there's only two ways that you can cross multiply, right? There's only two places that you can cross multiply. I'm gonna teach you a cross multiplying method in your what do you call it? Your subtraction and addition of fractions, right? And then also you can only cross multiply if it's an equation, right? If you have, let's say, x divided by 5 is equals to, let's say, 2x divided by 3, right? You can only cross multiply if it's an equation, or with the method that I'll show you as well when we do what do you call it? When we do subtraction and addition of fractions, right? So for now, let's keep the rule the same. Let's only follow this rule. Multiplications of fractions. Let's keep this rule the same, right? Okay, so when we simplify this, we basically have 2x squared plus 8x. And this is divided by, for the denominator, we have two brackets multiplying each other. So we can do that little method called foiling, right? So we would have x squared plus 4x minus 5. And that will be our final answer. Are you guys okay with this?
Isn't it minus 4x?
It's minus 4x.
It's minus
Minus,
4.
oh, sorry, yes, minus 4x. Thanks for correcting me there. Okay. So I feel like multiplication, you guys should be fine, right? That's all we need to do, guys. Like, honestly speaking, that's all we need to do. I'm gonna do one more example, and I'm gonna get this example from a textbook, right? So this example basically says if we have x squared minus 4x plus 4 divided by, and this is divided by x squared plus 2x minus 3, and this is multiplied by 6x squared minus 6 divided by x squared plus 2x minus 8. So please don't be tempted for don't be tempted by just multiplying this expression as it is, right? Try to first simplify it, as I told you previously. Always try to simplify it, and then, you know, by simplifying everything, it makes it easier for you to just multiply, right? Because multiplying these two brackets, you know, it's just gonna make a whole mess, right? But you can do that if you want to. but you risk getting what do you call it? You risk making mistakes. But please always simplify first. So how do we simplify this? Let's open two brackets for the numerator for the first fraction. And even in the denominator, we open two brackets. So we say x, we distribute our x's over there. And then for the 4, we can use a 1 and a 4 or a 2 and a 2, right? But this multiples of 4 just need to give us a negative 4. So the only one that we can use is the second one, which is a negative 2 and a negative 2, right? Likewise, we do the exact same thing for the denominator. We have a 1 and a 3, and we need to get to a positive 2. So we can say a positive 3 and a negative 1 will give us a positive 2. Multiplied by, let's take out a common factor for this one. Taking out a common factor for this one, we can take out 6. We'll be left with x squared minus 1. Hope you guys can identify what that is, right? And if you can identify what that is basically a difference of 2 squares. Let me just do it immediately. So we'll distribute our x and an x, 1, 1, positive, and a negative, like usual, right? Then over here, what do? We do the exact same thing. Open two brackets, distribute our x's, and then we find the multiples of 8. So 1, 8, 2, 4, right? And that multiples must give us a positive 2. So I can say positive 4 minus 2 will give us a positive 2, right? And then now let's find things to cancel out. Sorry, let's find things to cancel out. I can cancel out the x is equals to negative x minus 1 with the x minus 1. I can cancel out the x minus 2 with the x minus 2 over there. And then that's all I have left. That's all I can cancel out, right? Therefore, x minus 2 is remaining, multiplied by that 6, x plus 1, divided by x plus 3, multiplied by x plus 4. And then you can just leave it as it is, right? If you want to, you can just multiply everything inside if you want to. That's up to you. But you can leave it as it is. Actually, let's just multiply everything. It's fine. But I'll just leave the 6 outside. I'll just do this quick as well. And this will basically be our final answer. Add the negative inside as well. And then, yeah, that's basically it. So, let's do the division of fractions, right? And then we will be done for today. Division of fractions, and we will be done for today. So one thing I want you guys to know about the division of fractions is that it's basically the exact same thing as the multiplication of fractions with just one extra step, all right? So just one extra step, or yeah, one extra step if you want to call it like that, right? So let's say we have, here's the rule. Let's say we have A over B divided by C over D, right? We just have one extra step that we need to do. And that one extra step that I want you to do is you basically just need to change the division to multiplication and swap numerator with You swap the numerator with the denominator, right? So that's basically all you need to do. So in this case, we would have A over B. We swap, sorry, we change the sign to multiplication. Then we swap these two, right? So we would have D over C. That's always the case. Then after that, you have the multiplication of fractions, as I said, right? And then you just have AD over BC. You do not cross multiply. Do not cross multiply. Oh, sorry. You mean you want to cross multiply immediately instead of doing the symbol swap? Yes, you can definitely do that. You can just cross multiply instead of doing the symbol swap. You can just cross multiply like this, right? Immediately. But I would prefer you guys to do it step by step, because especially when the examples get, the expressions get very, very like big, right? They get very, very large. It's best to do everything step by step so that you don't make any mistakes, right? But you can definitely do that. It's going to give you the exact same answer. But cross multiplying, right? Please remember, you cross multiply this D to the A and then this C to the B over there, right? So please do it like that. Okay, let's do some couple of examples and then we will call it a day, right? I'm sure you guys are also tired. I'm sure you're tired of my voice as well, right? So we have x divided by x plus 2, and this is divided by x plus 3 divided by x minus 5, right? So remember, all we have to do is we just need to change the division to multiplication and swap the two around, right? Swap the two positions around. So this changes to multiplication. This x plus 5 goes on top. The x plus 3 goes in the denominator. So we have x minus 5 divided by x plus 3. And then over here, you can see we now have the multiplication of fractions. So we have x multiplied by x minus 5 divided by x plus 2 multiplied by x plus 3. And then simplifying this further, we just have x squared minus 5x divided by x squared plus 5x plus 6, right? And that will be your final answer. Pretty straightforward. Pretty straightforward. This is just the only extra step that you need to do. Just swap, and then you just change the symbol and then you swap, and that's it. All right. And then yeah, I think maybe let's just do one more and then we call it a day, right? So one more. We have x minus 5 divided by x minus 3. And this whole thing is divided by 2x as well, right? So I want you guys to notice that we can rewrite this whole thing as this is the numerator, right? I hope you guys notice that this is the numerator. So we can rewrite this whole thing as x minus 5 divided by x minus 3. And this whole thing is being divided by just the 2x. It's not being divided by 1 over 2x. It's being divided just by 2x, right? Please make sure you do not make that mistake. Okay, therefore, I can now say x minus 5 divided by x minus 3. Change this to a times. When I change this to a times, remember 2x divided by 1 is still the exact same thing as 2x, right? Then I can now change the symbols. I can swap the symbols. So I'll basically have 1 over 2x. And then therefore, I have x minus 5 divided by 2x multiplied by x minus 3. And then my final answer would be x minus 5 divided by 2x squared minus 6x. And that would be the final answer. Okay, so I think that's it for today. Okay, so in terms of with regards to the homework, right? We will do the homework. I'll give you guys homework for the whole chapter 0. So when we are done with 0,8, that's when I'll give you homework for the whole chapter, right? And then of course you just send it to the to my number, and then I'll respond to you guys, telling you guys if you guys got it correct or not. We will also have a test before the end of the month, right? So on the 28th, the lesson on the 28th, we will have a test, right? So please make sure you are ready and you know all these chapters. Okay, so I think that's it for today, guys. Thank you so much for attending the lesson, and have a great night.